research methods for sustainability, and the topic today is acquiring knowledge through research. So I'm going to talk about my perspective on why we need research to shape our knowledge, and so let's get into it. So why do we even conduct research anyway? Why don't we just accept people's opinion as fact and move along? So as I'm saying that, it sounds crazy, because think about all of the people in the world, and we may share some common values and goals and ideas, but we are very different, and then you get into different cultures. So all of our values shape our opinion, and we need something to verify these hypotheses and opinions as fact. And I use the word fact loosely because there are theorems, the law of gravity that has pretty much been tested, tried and true. But a lot of scientific data is evolving because our planet is evolving. So I use the term fact loosely, but there is better quality knowledge than other types of knowledge, or better quality knowledge produced by scientific verification than other forms of population of ideas. So with that, I just want to talk a little bit about what I thought research was prior to grad school, and now after having gone through the doctoral process. It took me 6 years, so I'm quite familiar with the ins and outs of what it takes to contribute a significant piece to the scientific data, and also what else is out there. So prior to grad school, I was a biology student, and for bio students, you spend some time in the lab looking at cells under a microscope, and then you might be drawing them, and you memorize the Krebs cycle, and that was what research was to me, just kind of drawing in a notebook and observing. And observational studies happen all the time. They happen more so in the field of ecology, biology, so that's sort of a niche field. But I didn't, as an undergraduate student, I didn't really fully understand the depth of research. So then getting to grad school, so when you first get to grad school, you have to do a literature review. Well, I guess I should take a step back. So first, you have to develop a hypothesis. So what you want to base your question upon. And for me, I was really, really interested in studying eco-villages because I see them as models of sustainability. They are places where people intentionally live off the grid, live with less. A lot of people don't drive cars, so they use other modes of transportation if they can help it. So I really wanted to investigate if these lower energy societies are still able to participate with the rest of the world. Because it's one thing to go off into the wilderness and never talk to anyone, and we can't all do that, but we can maybe live in off-the-grid residences but still maintain our daily work life and be able to have viable incomes. And so when I formed that question, and my hypothesis was I thought these were both lower energy societies that still contributed to the broader society, I needed to do a literature review. And every scientist needs to do a literature review, and I know there's a whole module on them, so I'm not going to go into disgusting detail right now, but it's important to just bring it up briefly, because why are you doing what you're doing if someone else has done it? So the first step is to look into the literature and see if someone has already addressed your question, or maybe they haven't addressed your specific question. For my case, maybe someone studied intentional communities in the Arctic. So they have data, and I could take that data and compare it to a place that is located in a more temperate area, because those two conditions are not the same, different energy requirements altogether. So sometimes data that you find during a literature review is complementary, and it guides you in a direction that you should be going into. But it's very, very important to know the broader context that research fits into. Let me consult my notes. So yeah, my perspective on what research totally changed as an undergraduate student to a graduate student, and I have a much greater appreciation in the amount of time, energy, effort. Oftentimes research can be very, very tedious, or you can go down a path and study something for a month or two and then toss out that data because you didn't need it, or your advisor says it's not good enough. So research and knowledge is an evolving process. It's my opinion that we will never fully know the truth, because we are all sort of co-creating what this world looks like, and so it's going to constantly change. I don't ever see the world as being in a constant state of equilibrium and balance, but who knows, I could be wrong in a couple hundred thousands of years, especially if people aren't here anymore. Things might not change as quickly, or our need to acquire knowledge might not be as strong. But present day, we are constantly learning new things about our environment. So the next topic I want to talk about relating to this subject, so different types of knowledge and different quality of knowledge. So as a scientist, we go through peer review. So in order to publish anything in the literature, we need to have our data and our process, our technique, verified by people who are experts in our area to give that stamp of approval and say, yes, they did their research in a way that meets a certain level of maturity, and what they did would have produced viable results. So this belongs in literature for other people to read and take data from, essentially. But a lot of what scientists do never make it to the literature, and that doesn't mean it's not as valid. There are various reasons why not to publish, or maybe someone else came along and did a study similar to yours, and so they kind of beat you to the point. But the literature is really the gold standard of where to find the most accurate information. And unfortunately, the general public does not read a lot of scientific literature. So unless you are in a class in academia, you may not go on Google Scholar and search for the most accurate data. And so I look at scientific literature, again, as sort of the gold standard, and the rest of, or a large majority of citizens, especially in the US, they're subjected to what the media puts out there, and the media can be very biased on both sides, both left and right. You can look at a website and see where various media outlets fall on the political spectrum, and most of them are not neutral or are nonpartisan, so you have to be aware of that. So the good thing about science is that it attempts to take all of that bias that we find in the media and negate it. So science should be unbiased. Now, does that always happen that science is 100% unbiased? No. Especially, you have to look at funding for certain studies. If oil companies are paying for studies that say the certain technique of extracting oil is safer than another technique, you should really look into why they funded that study. So there can definitely be bias. On rare occasions, someone just really wants to get their name out there in the scientific community, and so they'll publish literature that maybe doesn't have a lot of substance, but it could be surrounding a controversial topic. So science isn't 100% foolproof, but in my opinion, it is the best way to acquire knowledge. Okay, so building off of that, so I would consider myself a scientific generalist. And what that means is I know a little bit about a lot of systems. So if I go out and study a wetland system, I know the general function of a wetland. I know what kind of energy flows I need to calculate. But I am not a wetland ecologist. I don't go out there. It's not my life's work to spend hours upon hours in a wetland, even though I've helped some of my colleagues out in the field with research in wetlands. And in Florida, they're hot, sticky, buggy places. So I'm happy that I'm not out there all the time. So they're the specialist, and me as a generalist, I rely on those specialists for data, because there's so many things in our world. I can't collect everything. I could spend a lifetime just in one field. But the issue is the silos that form. If you're a specialist, these information silos, if you don't share your work, then you're just within your own little scientific community, you're just perpetuating the same ideas. And especially for sustainability, or sustainability fields, we're so interdisciplinary, and so it's really, really important to share ideas and collect data from various fields and put them together and try and make predictions based on this holistic data set about where our world is going. So that's another important thing to think about when you're acquiring knowledge through science is, what is this person's background? Are they just focused in one area, or are they looking at the bigger picture? Okay, so since I am the new sustainability policy concentration director, I just wanted to talk again briefly about the media. So especially in this current political arena, there's a lot of fake news out there, or a push on the attack for an attack on media, that they're conspiring and they're putting out fake news, and just an attack on science in general. Like, people, the general public, tend to not have as strong of a trust in science as they used to, and that's really an attack on our democracy. You plant seeds of doubt, and all of a sudden you don't know what to believe, and so you just believe someone that you think has got your back or will support your own personal agenda. And that can be very, very dangerous, especially so the Environmental Protection Agency has recently lost a lot of funding to carry out their job. And of course, that is our premier agency, that their main goal is to regulate environmental damage. But they also create research. So government policy dictates the scope of their projects, but then they also produce a lot of research, which in turn, there should be this cycle, produces better policy. So currently that has been disrupted a bit, especially having politicians that are climate change deniers. You can't even say the word climate change. And so there's been an attack on research shaping our knowledge currently, and again, that's very, very dangerous. through this module, I want to leave you with the idea that knowledge is power, but there's definitely varying degrees of quality of that knowledge. And so we as people in academia, that is our quest, to find the best knowledge through the scientific process. And there are various ways that we can conduct research. Throughout this course, we're going to be talking about various modes of collecting data, qualitative, quantitative, and you'll get an overview in this class. By no means is it exhaustive, but it is our hope that through taking this class, you will have a better idea of what type of research you would like to do if you go on to do research. But everyone should really take a research methods class because we acquire knowledge every single day. We all go through the scientific method. Whether we realize it or not, we have a question and we logically work it out. So it's a the scientific method is a very, very powerful tool. Okay, so that is it for this module. I hope you all have a good day.